This is Unit 5 and we are talking about extreme value theorem. In the previous unit, we investigated heavily how to locate relative extrema. Relative extrema means how do you find it? You take a derivative, make it equal 0, critical points, and then sign chart. And positive to negative, negative to positive. That's what relative extrema goes. Of the function by using the derivative. In pre-calculus, we talked about the difference between relative and absolute extrema. In the space below, distinguish between two. So now we are talking about in this unit 5 absolute extrema actually. But you have to know the difference between relative and absolute extrema. So relative extrema are points like x and y both. In relative extrema, we always try to give them an order pair like x and y both. You have to get the x and then you plug that in the original to get the y value. So that's why they said a points where a function changes from positive to negative, or you can say from increasing, or you can say positive to decreasing, or negative, or vice versa. Absolute, what is absolute? So absolute extrema are the points on a graph with the greatest and or least y values. So absolute is just a regular y values, and you look for the extremely greatest or the least y values, and that's your absolute maximum and absolute minimum. So let's try these and it will make more sense when we do examples. Picture below are the graph of f and g. Answer the questions about these two functions. Identify the coordinates of relative extrema of f, and this is f graph and that's g graph, which means these are both of them are my original graphs. So if I'm looking for a relative minimum and maximum, relative maximum and minimum deals with the relative maximum and minimum deals with what is it called, derivative, first derivative. We make them equal 0 and we get the sign chart and count critical points and all of that. So since this is original, I have to draw tangent lines so I can get my relative extrema, which means positive to negative and negative to positive. So on this one, when I draw the tangent slopes here, I'm getting negative slopes. So if I draw tangent lines here, I'm getting positives. Draw tangent lines here, I'm getting negatives. Tangent lines here, I'm getting positives. So you can tell where it's going positive to negative and negative to positive. If you check the first one, I'm going negative to positive, which means at negative 3, 0, I have a relative minimum. So let's try relative minimum. That's the first one, so we can do that. Relative minimum is equal negative 3, 0, and we have to give them a point like x and y. Negative 3, 0. Then this is also negative 2 positive, which means 2. And negative 6 is the y value. So 2 and negative 6 are my relative minimums. Now what are my relative maximum? Maximum means positive to negative. So this is positive and that's negative. So this is negative 1. The sign changes at negative 1. So it's negative 1 and the y value is 3. And I think that's the only one. I don't have another one because this is negative to positive, so I don't have another one. So these are my relative maximums. How do we get the absolute extrema of f? On the domain of f, what are the coordinates of the absolute extrema? Absolute extrema, the lowest, like the lowest point, like a y value, or lowest point, lowest y value on the graph, and highest y value on the graph. If you check this whole graph, the highest y value is going towards infinity, like it's going in this direction, so that's the highest y value I have. But the lowest y value is -6. And what is that x value? 2. 2, -6 is my lowest y value. So I'm going to say absolute minimum, absolute, like the lowest and the greatest y value on the graph. Absolute minimum is equal to in -6. Do I have absolute maximum? No, I don't. Because it's going towards infinity, I don't know what that, infinity is not a real value, so we're going to say none. So let's try this graph, the g of x graph. And now it says identify the coordinates of relative extrema of g. So I'm going to draw tangent lines again. This and this is negative slopes, negative and negative. This one up here all the way, these are all positive slopes. These are all negative slopes, negative tangent slopes. These are all positive tangent slopes. Okay, so let's see relative extrema. From this is negative, so from negative to positive, I'm going on -3 and -4. So relative minimum is equal -3, -4, -3, -4. And union, and I'm going negative to positive at 3, 2, at 3 and 2. Relative maximum, relative maximum, where I'm going positive to negative, which is -1 and 4, -1 and 4, and that's the only one maximum I have. Now, this question on the domain of G, what are the coordinates of the absolute extrema? Since I said absolute extrema means the y values, So in this whole graph, since this is a closed interval right here and right here, so we're gonna count all of those. Since this one was like arrows, which means it's going towards infinity, so we didn't say anything. But in this whole graph, where is the least or the minimum y value? If you guys look at this, that one is in the bottom, the y value is 2, but this one is the really down the bottom, which is -4. So that's my absolute minimum, -4, but I'm gonna say -3, -4 as an order pair. So you're gonna say absolute minimum is -3, -4, -3, -4. And what is that? Like absolute means like globally, like on the overall graph, what is the minimum and maximum? So absolute maximum, and in here we have maximum because we have these dots, and this is the absolute maximum because that's the highest y value we have. That's 5, this one is 4, that one is 2, so that's the highest, the greatest y value, 5. And the order pair is supposed to be 6 and 5, so that will be 6 and 5. That's absolute maximum and minimum from the graph, and then I will show you how to get it from the equation. On the domain of a given function, did the absolute extrema occur at function's relative extrema? On the graph of f, you can say on the graph of f, the absolute minimum, occurred at a relative minimum, at a relative minimum, and like these are on the, this is graph of f. So the absolute minimum, this is absolute minimum occurred at 2, -6, and this is occurred at one of the relative minimum. We have two of those, but it's one of them. And on the graph of g, and on the graph of g, the absolute minimum occurred at a relative minimum, but its absolute maximum, like absolute minimum is -3, -4 occurred at relative minimum, but absolute maximum did not occur at one of its relative maximum. Okay, question, the next one. Let's see the next one, how it goes on the intro. Okay, on this question, on the interval -2 to 3, what are the absolute extrema of f? So -2 to 3, so I'm going to highlight -2 to 3. This is -2 right there to 3, all the way to 3. So I'm gonna go in green all the way to 3. And then we find absolute maximum and absolute minimum. That's a 3. So 3 actually going all the way up there. So in this case, when I see absolute maximum, which one is the greatest y value? So I can see the 3 is the greatest y value, the 2 is the greatest y value, and I have this infinity. Infinity is not a real number, so I'm not gonna count this because of the arrow. It's going forever, so we call this infinity, like it's going in this direction. So the only thing I see is the maximum is the greatest y value is 3. So what is the x value for that? It's -1. So that's my absolute maximum, -1 and 3 as an order pair. Now which one is absolute minimum? The minimum, the least, the smallest y value is right here, -6. So what is the x value for this? 2. So that's my absolute minimum, which is 2, -6. Done. Now let's try this one, -4 and 1. So I'm going to use a different color for it. It's starting with -4 and 1. So this is -4, like -4. And if you guys pay attention, -4 and -1. Okay, I made a mistake here. If you guys pay attention closely, I moved this green arrow all the way up there for 3, but since it says 3 closed interval, so I'm supposed to stop there, which means, let me erase that. I'm supposed to stop at 3 right here. This could be 3 something 3, but it's right there. I'm supposed to stop because it's closed interval. I didn't pay attention to the closed one. But let's try this one. So -4 and 1, so it's supposed to be closed. So I should have a point somewhere like right here. This is -4 and 4. You know, 5 is going like just a little bit over here. So that's 4. So I'm going to go from -4 to +1. So -4 to +1. What is +1? This is +1, and I think +1 goes all the way up here. Right there. That's +1. So now what is my absolute maximum and minimum here? Absolute maximum, my absolute maximum is this, that's the y value, which is the greatest one, it's -4 and 4, and my absolute minimum, which is going to be -3, and 1 is x value and -3 is a y value. There. Now let's go for this one. On the interval -4 and 5, so I'm going to start -4, and both -4 and 5 are closed intervals. So -4 start here. That's -4, that one. And it's going to go all the way to 5. So I'm going to go -4 and 5. That one, I can't see that color. So -4 and all the way to 5. Where is 5? Right here. I'm going all the way up there. So this whole graph is -4 and 5. What are the absolute extrema? So which one is the greatest y value? If you see, this is the highest point on the graph, so that's a 5. I mean, I don't have anything other than highest than that. So I'm gonna say absolute maximum is that's 5. So what is the y value? 6, 6, 5. I think let's try the absolute maximum is, okay, I made another mistake. If you guys pay attention closely, which I'm not, I think they said -4 to 5, so -4 is right there, 5 is right here. I don't know why I went all the way there. This is 5. Here we go, that's a 5. So the highest y value is this one, 4, and for that one it's also 4. So 4 and 4, I have 2 of those. So my y value, I have 2 absolute maximum for the y value 4. So this 4 is -1 and 4. -1, let me erase that. -1 and 4. And I have this one, which is 5 and 4. So I have 2 absolute maximum there, because I have 2 points that has a y value, the highest one. The lowest y value is this. I can see that's the lowest y value on the graph, which is -4. So absolute minimum, I'm looking only the y values, but I have to put them as an order pair. So this is -4 and the x is -3. So -3, -4. Done. Next one is on the interval -2 to 6. So this is -2, and -2 starts here and to 4. So I'm going to go all the way to 4, which is right here. That's the yellow one. So the highest, the absolute maximum, the highest y value is this, which is 4, and the x value for that is -1 and 4. Or, -2 to 6. I don't know why I stopped at 4, but it's 6 right here. So the greatest y value is 5, which is 6 and 5. Okay, so that's 6 and a 5. There. And I have absolute minimum. Minimum is that one, which is -2, 0. There. Guys, you have to really closely pay attention to the intervals. Like I messed up on several questions, so you better be paying attention closely. Let's see this. When the domain is restricted to particular closed interval, at what 3 places that the absolute extrema could exist? So when the domain is restricted, all these domains are restricted, then we found that where the absolute extrema exist. Extrema exist at the endpoints. The first one is at the endpoints, of the closed interval. Of the closed interval at the endpoints. Okay, because if you guys check, These are my endpoints. Like this is negative 4, what is this? Negative 4, 4, and this one is 3 and 1. It exists for the green one. At the endpoints that exist, the absolute extrema, and also absolute extrema exist wherever at any x value where f prime x is equal 0 or undefined. That's where their absolute extrema exist, because if you check this portion up here, I'm just picking this graph randomly, this portion is undefined. But if the extrema exists, then exists because it was negative 3, negative 4. That was absolute minimum. Same goes here. And if the values, if the f prime is 0, like if I draw a tangent line, because these are original graphs, so I can draw tangent lines and make it equal 0, which is this portion equals 0, this portion equals 0. Again, this one is also absolute minimum for the green one. So we can say that. The third one, we can also say, I think that's enough, or undefined, yes. The extreme value theorem. So what is extreme value theorem? So please pay attention. So far you guys only did intermediate value theorem, where it would say C is between A and B and K is between f of A and f of B. And the K means any Y value they would give me, for example, K negative 3. So I would, if they want you to find the C, then you're gonna make the equation equal negative 3, like f of x equation equal negative 3, and you solve for that C. C means that x value. But this is the only, and the condition for this one, it has to be continuous. And the C between A, B, and K between f of A and f of B. Extreme value theorem says if f of x is continuous on closed intervals A and B, then there exists an absolute maximum and minimum on closed interval AB. On closed interval AB at either x equal A, x equal B, or any value of x on AB, such that f prime x is equal 0 or undefined. Okay, that's extreme value theorem. So the take is, for the extreme value theorem, it has to be continuous. And if you have closed interval A and B, you must have absolute maximum and absolute minimum. That's what the extreme value theorem means. Okay, let's see. Picture to the right is the graph of the function this. And on the closed interval negative 4, 1, use the graph to answer the questions to the left. So identify the absolute maximum of f on the closed interval negative 4, negative 1. Identify the absolute maximum. So the highest, or the how do I say that, greatest, biggest y value, or the highest y value. So negative 4 and negative 1. So I'm going to start negative 4. This is negative 4. It starts with negative 4. It's a closed interval. And I'm going all the way to negative 1. Negative 1 is right here. And both of them are closed intervals. You can see it. So I have to have a maximum and minimum. That's extreme value theorem says. And it is continuous. So if I have this, then what are my absolute maximum? I have this one, that's the highest y value, and this is the highest y value, which means I have two absolute maximum. Negative 4 and 6, negative 4 and 6, and this one, negative 1 and 6. And like I said, it has to have a maximum and minimum. Since they're asking just maximum, then I said, okay, that one. But look at the minimum. The minimum on the closed interval, the same, and this is the minimum. That's the lowest y value, which is 2, and the x is -3. So that's -3, 2. Identify the absolute maximum of f on the closed interval -4 and 1. So this is -4. I'm going to start with -4 again, and I'm going to go all the way to +1. Where is +1? And +1, and if you guys check, +1 is a closed interval. So I have to stop at the y value wherever the 1 is, and I think it's all the way down there, -14, or this one. That's the one. So this whole graph they are talking about actually absolute maximum. Which one is the maximum y value? You can tell this and this is the maximum y value, both of them. So I'm gonna say -4 and 6 again, and -1 and 6. Minimum is now this is the lowest one. So this is 1, -14. X value is 1, and -14 is a y value. So that's the minimum. That's the lowest one. And since I have a closed interval, I have to consider that. Okay, now let's see this. Use extreme value theorem to locate the absolute extreme of the function on the given closed interval. Your algebraic results should concur with your graphical conclusions above. So these are my graphical conclusions, and these are my restricted domain, -4, -1, and -4 and 1. And see if we have exactly getting the same answer using the algebraic way to find absolute extrema. Now there, I already gave you the steps for a relative extrema. The relative extrema was, if you guys remember, I'll just remind you, it was derivative, make it equal 0, critical points, and then we make sign chart. If we go positive to negative, that's a relative max. And if I go negative to positive, that's your relative min. Now for the absolute, I also have steps. What are those steps? The first step is you take a derivative, you're going to make it equal 0, you're going to get critical points. You're not making a sign chart in absolute extrema or absolute extrema. You don't do that. You're going to just plug in that critical points and endpoints, whatever restrictions they give me, endpoints in the original equation, and see which one is, and look for the highest and lowest y values. Always the answer for relative extrema has to be is in order pair, and if you give this is order pair, that would be so nice. But if you just give them y value, that's fine too, but this one has to be in order pair. Okay, let's try. So I'm going to use this one step, take a derivative. So my function is f of x equal -x cubed minus 6x squared minus 9x plus 2. I'm going to take a derivative of that. -3x squared minus 12x minus 9. Then I'm going to make it equal 0. Now if I make this is a quadratic, so after calculus, when we get stuck, remember the functions that we do least common denominator, we do FOIL, we do distribution, and we do exponent properties we use, or we factor. Factors are two types of factor. Either you're going to do this factor, like two factors like this, or you do common factor. So I'm going to do common factor first because I can see 3 is the common factor between them. I always consider common factor first. So -3, so I got x squared plus 4x plus 3. Now I can factor this out like the two different factors. So I'm going to go, -3 is going to stay. So I have two factors. I have x plus 3 and I have x plus 1. So these are my factors. Now make them equal, each one of them equal each other. So I'm going to go x plus 3 equals 0. I'm going to go x plus 1 equals 0. This is going to give me -3. This is going to give me -3. This is going to give me -1. And -3 equals 0 doesn't make sense. Like it's not equal, so we don't do that. So I got -3 and -1. Now plug them in. -3 in the original, plug -1 in the original, plug in the end points, which is -4 and -1. So -1 is already here, so I just put -4. So you get the y values for each one of them and see where is my absolute maximum and absolute minimum. So let's plug in the original equation -3. If I plug in -3 here, so I'm using a calculator and I'm doing -3. When you plug in, it's going to give me 2. When I plug in -1, it's going to give me 6. When I plug in -4, it's going to also give me 6. So which one is my absolute max and absolute min? So I'm going to give them as an order pair. I'm going to say f of x has an absolute maximum at, since I have two maximum, 6 and 6, I'm going to say -1 and 6. Like that's the x value and that's the y value. And I'm going to say -4 and 6. And I also have f of x, that's one. The second one, f of x has an absolute minimum at -3 and 2. So that's my answer, and that's easy, very easy for the absolute extrema to figure it out, and this is only one step that we use here. Okay, let's try this question. -4 and 1, and this is my, and I already know f prime x. I can write my f prime x. This is -3, x plus 3, and x plus 1. I already showed you guys all the stuff. So this is my f prime. Now again, I'm going to plug it in -3. I'm going to plug in -1. I'm going to plug in my endpoint, which is -4 and which is 1. So these are all my endpoints and the critical points. -4, we already know it's a 6. We already know -1 is also 6 because we already did this over here. -3, when I plug in, it's going to give me 2. When I plug in +1, it's going to give me -14. So what is my maximum and minimum? I can say f of x has an absolute maximum at, maximum is 6 and 6 again. So I got -4 and 6, and I got -1 and 6 because these are the highest y values. F of x has an absolute minimum. The smallest number is -14. You know, negative numbers, that's -14. So at 1, -14. That's it. So let's see. For each of the following function stats specific state specifically why the extreme value theorem is or is not applicable on the given interval. Remember, for the extreme value theorem, it has to be continuous, and they said the values are -4 to 0. So is this function continuous? The only thing I can see is not continuous because is my vertical asymptote. If you guys remember the discontinuity, either it's going to go whole, or jump, or what is it, jump, whole, or vertical or horizontal asymptotes. These are the few things that we consider them not continuous. So I don't see a whole. But I can see a vertical asymptote, which is -3, is -3 between -4 and -5 and 0. Yes. So -3, the vertical asymptote is between -5 and 0. So it's not continuous between -5 and 0. So intermediate extreme value theorem doesn't apply. So I'm going to say the EVT is not applicable. This is only one condition for the EVT if it's continuous. For h of x on -5 and 0, because h of x has a vertical asymptote at x equal -3. You know that you make this equal 0. 3, which is on the interval -5, 0, and they are closed intervals. So, closed intervals. Okay, guys, this is vertical asymptote when the denominator make it equal 0. This is when you do the horizontal tangent, you make this equal 0. That's a vertical tangent, you make this equal 0. But for the horizontal asymptote, you just have to use shortcuts. Horizontal asymptote is always approaches infinity, like limit approach infinity. So if I use a shortcut, then degree of numerator, degree of denominator are exactly the same. So 3 is your horizontal asymptote. But if they were asking horizontal tangent, then you make this equal 0. And vertical tangent, you make this equal 0. And vertical asymptote also the same. Okay, let's see this one, this graph. Let's figure it out. 2x square root x minus 3. I can see between -4 and 0 in the closed intervals. I see x minus 3 like the square root. I know the parent function for the square root x. It goes something like this. So it means I'm going to the right 3 times. So my graph starting here, this is 1, 2, 3. So my graph is gonna start here, and this is going like in this direction. But it's going towards infinity. It's not between -5 or 0 at all, because -5 is, I know it's over here. I mean, I can tell by just doing the parent function for this. I don't know exactly how it looks, and I'm not using a calculator, but I can tell it's going towards in this direction. So it's greater than 3, like x is greater than 3. It's going in this direction. So that's why it's not between -5 and 0. So it's not continuous between -5 and 0. So I'm going to say the domain of g of x is 3 to infinity, which means EVT, extreme value theorem, is not applicable. Because g of x is not defined. Like, I don't have it there from -5. It's not defined at all values. It is defined from -3 to some points, but it's going towards infinity, which is not a real value anyway. At all values on the interval, -5, 0, closed. Okay, let's try this one. ln x plus 7. For the domain, if you're trying domain, always domain goes like this, like x minus 3 greater than 0. This one is gonna go x plus 7 greater than 0. So I'm gonna go x greater than -7. So an ln x graph, when you see it, it's something like that. It's going like that. So it's going from -7 to infinity, like it's like this. This is -7. So it start here, it's gonna go like this, but it's going towards infinity. That's ln graph. So I'm starting here at -7. I'm starting here at -7, but it's going in this direction. So I can say, since the domain of f of x is -7 to infinity, f of x is defined and continuous on -5 and 0. And you can tell that. I know my domain is going -7 to infinity, But you know, my domain up here restriction is -5 and 0. So for example, this is -5 and that's 0. So between -5 and 0, I am continuous. No, nothing else is there. On -5, 0, and the EVT is applicable. There. Given the function below, determine the absolute extrema values of the function on the given interval. Guys, if your calculator is allowed on this, and it's easy peasy, graph them and figure it out. Extreme value theorem is applicable if it is not, state specifically why it is not applicable, or if it is applicable, then determine the absolute extrema. So let's try question number 1. I'm going to take a derivative f prime x equal, first of all, can we check if it's continuous on -1 and 3, and every polynomial is continuous. This is x cube, again the parent function helping me here. X cube means that my graph goes like this, so I can tell from -1 to 3 it's continuous. Like this is -1 and I can tell this is going up there, so it's continuous. So I'm gonna say, and every polynomial is continuous, so I'm taking a derivative, which is this, and I'm gonna make it equal 0. Then a common factor is not 3, and 3 times 1, I don't see the factor for this, but the easy way to do it, we can graph this. These questions, the one we can't do this, they're gonna give you on a calculator. You would be able to use a calculator. So I'm gonna use my calculator here and see how it goes. I'm gonna graph this, and I'm gonna graph 0, and I will find a point of intersection. That point of intersection is gonna give me my x values, so we would be able to know what are my critical points. So because I have to know the critical points, and I'm gonna plug in endpoints in the critical points both. So here we go. Let's see, add a graph, and my function that I have, the derivative one, it's 3x squared minus 4x minus 4x, and I have -3, and I hit enter, and I'm going to open another tab, and that will be 0, and enter. So my point of intersection is 1 this and 1 is that, 1 negative, 1 positive. So how do I find exactly those? Analyze graph, and you can see intersection. So I'm going to move this dotted line over here, because I know when my intersection is this. So I'm just going to go lower bound, I'm going to go upper bound. So I have -0.535, and the other one is right here, 1.869. So let's go back here. So my x values are, x is equal -0.535 and x equal 1.869. These are my critical points. Now I'm going to plug them in the original, -0.535, and I'm going to plug in 1.869, and I'm going to plug in -1, and I'm going to plug in 3, because we have to plug in endpoints too. So these are all my values that I'm going to plug it in the original. Okay, remember original, that's why I have the f. When I plug in -0.53, I got -1.121. When I plug in 1.869, I got -8.065. When I plug in -1, I got -2. I plug in 3, I got -2. So you can tell which one is absolute maximum and absolute minimum. And these are all negative y values. The greatest y value, negative y value, means that's the smallest, like a least. That's absolute minimum. So I'm gonna say f of x has an absolute maximum at x equal, what is my absolute minimum? Minimum is negative absolute maximum, sorry. So this is the smallest one. The smallest one means that's the biggest y value, like it's maximum. So I got x equal, no, it's not x equal, maximum value at x, don't say x, just put the order pair, negative 0.535 and negative 1.121, and an absolute minimum is, minimum is this one, 1.869 is x and negative 8.065 is a y value. So that's my maximum and minimum for this question. Let's try that one. Pi over 2 and 2 pi is my restriction, and this is my g of x function. I'm going to take a derivative of this, and remember, if your square is on trig, you can rewrite this like that. The whole square goes on the top of this. So that's actually my chain rule. So 2 jump to the front, and every trig is a chain rule anyway. Keep everything inside as it is, times the derivative of inside. Inside is again my chain rule, which means that outside and that inside. So I'm going to go outside derivative, which is cosine. Inside stays as it is, and the inside derivative is 1. Plus cosine x derivative is negative sine x. So I'm going to fix it around. So I got g prime x equal 2 sine x and cosine x minus sine x. So this is my g prime. I'm going to make this equal 0, and I'm not going to bother to do it without a calculator. I'm going to use a calculator for this. So let's clear that. Now use a graph again. Let's try 2 sine x. I got 2, a trig, I pick sine x, and I got cosine x, cosine, that's not supposed to be here. Let's delete that. Move the cursor, and now I can do cosine x. Cosine x, move the cursor. Then I have minus sine x, minus trig, and that's sine, and this is x, and enter. And also, I don't need this whole thing. I need within the restricted domain, like pi over 2 and 2 pi, because that's what my restricted domain was, pi over 2 and 2 pi. So I'm going to keep the window as it is so I can see exactly. But let's try 0, 2 in the another tab. Here we go, that's 0. Now go to menu. I need a window, in the window setting. You don't have to know what pi over 2 is. I'm just going to type in pi over 2. So where is my pi? Pi. This is pi. Divide by 2. And then another one is 2 pi over here. Let's delete that. And I have 2 and again a pi. And then, okay. So this is my pi over 2 and 2 pi. That's what the restriction, the point of my point of intersections. One is right here and one is right there. So I'm gonna find my point of intersection by doing analyze graph intersection, and one is right here. This one is 3.142, which is technically pi. If you guys remember, 3.14 is a pi. And another point of intersection that I need is this, and this is 5.236. So let's go back, and I'm gonna say my x values are, one is pi, or you can just write 3.142 because that's what it was, and another x value that I got is 5.236. Now I'm going to plug these in the original. So pi plug in, then you plug in 5.236, and you can plug in the endpoints, which is pi over 2, and you can also plug in 2 pi. So plug in pi. When I plug in pi in here, I can tell, I can use a calculator to plug in the pi since I used a calculator for everything, but you can also go ahead and check your, let's go back to the original. I'm going to try original now. Parentheses, I got sine pi, and then move the cursor, and then I have a square. Then I have plus cosine, plus trig cosine pi. Now enter. It's -1. So I got -1. So the pi got -1. Now we're going to plug in 5.236 pi over 2 into pi. So go back to the calculator. What I'm going to do, I'm going to highlight this and I'm going to hit enter. Okay. When you hit enter and highlight, then you would be able to change all of this. So instead of pi, I can say, let's do 2 pi first because it's kind of easy to. That's 2 pi. Then hit enter. I got +1. So for the 2 pi, I got positive. 2 pi got +1. Pi over 2. Let's do pi over 2. So I'm going to highlight this one more time and I'm going to hit enter. So I change this to pi over 2. You delete. This is going to go pi divided by 2. You delete this and then you do here divide by 2 and hit enter. It's going to give me +1 again. So I got 1 again there. Then I got 5.236. Let's do, I highlight this again. And when you click use a real calculator, you're going to go back there, like go and press this arrow thingy, and then it will highlight automatically. So I'm going to hit enter and I change this to 5.236, and then I'm going to highlight this, delete, and I have 5.236 and hit enter. It's going to give me 1.25. So let's go back, and this is 1.25. So here is the maximum and minimum. So you can tell g of x has an absolute maximum value of, if I use the word maximum value of, then I can just say y values, like I don't have to say anything. Maximum value, which one is the biggest one? It's the 1.25. And an absolute minimum value of -1. So if you use the word value with maximum and minimum, then you just put the y values. But if you say has an absolute maximum at this, then this is going to go like we did in these questions. So this is what it is. Let's do question number 3, and I have question number 3. Okay, take a derivative, -3 and 6. Is this continuous on -3 and 6? Let's see if it's I think it's continuous on -3 and 6. So let's take a derivative, f prime x. It's a chain rule. 2/3 jump to the front. Inside stays as it is, and 2/3 subtract 1. 2/3 subtract 1 is going to give me -1/3 times the derivative of inside, which is 1. Let's fix this around. Then I'm going to make it equal 0. So I got 2/3, and since 3 is already in the bottom, I can move this to the bottom, x plus 2 with the cube root like this. So that's what it is, and I'm going to make it equal 0. Now the derivative, make it equal 0. But the thing is, when I had the derivative, make it equal 0, I have this, make this equal 0 doesn't make sense. So I'm going to make this whole thing is equal 0, like x plus 2 1/3, like this equals 0. then you times 3 both sides, times 3 both sides. They cancel out. I'm left with x plus 2. X plus 2 equals 0, and it's going to give me x equal negative 2. This is what I got, negative 2. So negative 2 is my critical point, so which I am going to plug it in the original. So f negative 2, and I'm also going to plug in f negative 3 and f6, all of this. When I plug in negative 2, I got 0. When I plug in negative 3 in the original, I got 1. When I plug in 6 in the original, I got 4. So I can say f of x has an absolute maximum value of 4 and an absolute minimum value at minimum value of 0. You can say that one is 0. Yes. Okay. So this is what it is. Let's try this one. I'm going to take a derivative of that. I don't know. I have to check negative 1 and 3 if it's continuous on negative 1 and 3. This is ln function. So ln function, if I graph this, I'm going to try to graph it. Go to on, graph, doc, clear the scratch pad. Okay, now let's go on graph. The first one is, let's graph that, the one we had. So I'm going to go control ln, and I have x squared minus 4, and graph it. I want to see the graph negative 1 and 3. Okay, so I can tell this is negative 1 and this is all the way 3. And from negative 1 to 3, you can change the window so you would be able to see it clearly from negative 1. So I got negative 1, and this one is 3. Negative 1 and 3, and enter. Look. This is negative 1 and this is all the way 3, so I'm not continuous on negative 1 and 3 at all. So it means this EVT is not applicable. The EVT, extreme value theorem, is not applicable because at x equal 2, which is this domain thing, like x squared minus 4 equals 0, you're going to say x squared equal 4, you square root, it's going to give me positive negative 2. Because at x equal 2, this positive 2 is not between negative 1, positive 2 at x equal 2, which is on negative 1 and 3, but each of x is undefined and not continuous. Is not applicable at 2, because at x equal 2, at x equal 2, which is on negative 1 and 3, each of x is undefined, and I'll tell you why it's undefined and therefore not continuous. Okay. Continuous means when my graph, I mean, you already checked on the calculator. It's not continuous between negative 1 and 3. But why, if I'm not using a calculator, how do I say, because 2 and negative 2 and positive 2 is between negative 1 and 3. Yes, it is. But why would I say it's not continuous on there? Because algebraically, when I'm not using my calculator, algebraically, you can tell when you plug in this positive 2 or negative 2 in here, you're going to get 0, like ln 0. ln 0 is a big no. It's giving you error. There is no ln 0. You have ln 1 is equal 0, which is completely fine, but ln 0 is giving you an error. It's undefined. When you plug this in the calculator, it's an error. So 2, when I plug in 2, it's going to give me 4 minus 4, which is 0, ln 0. So that's why it's undefined. It's not working here. If you guys have any questions, please ask me, comment below and ask me.